All right. Good morning, everyone, and good evening, Greg. Welcome to this talk at National Yangming Jiao Tong University. We are happy to have Professor Greg Scontras as our first speaker in this colloquium. Professor Scontras is a semantist. He got his PhD from Harvard in 2014. During the past several years, he published a number of papers which are about the semantics of numbers, measurements, and adjectives. And he also works on heritage language and language acquisition. As you can tell, he is very, very productive. Now let's welcome Professor Scontras.
Thank you so much, Louis, and thank you guys for the invitation. I'm excited to talk to you. So let's get going. The starting point for this talk is the observation that it doesn't take a trained linguist to make, namely that kids sometimes use language rather differently from adults. And we wanted to know where those differences were coming from. Is it the grammatical knowledge that kids have that's differing from adults? Or is it the way that they're using that knowledge in context that is different? So that was the starting point. Where I think we wound up is with a cautionary tale for the truth value judgment methodology. So this is a go-to method for trying to understand linguistic meaning, especially in children. And I think, well, you can decide how pessimistic the take is on this methodology after I present what I have for you. But first, okay, so what is that methodology? Suppose that we're in a world with 3 horses, and horse number 1 jumps over a fence, and then horse number 2 jumps over the fence, and horse number 3 decides that she's tired and she's not going to jump over the fence. So you're left with a scenario that looks something like this. You have 2 horses that have jumped over the fence and 1 horse that hasn't jumped over the fence. And now suppose Mary here comes in and she says, I know what happened. Every horse didn't jump over the fence. So do you think that what Mary said is true of that scenario? You can consult your own intuition. Now, that is a truth value judgment that you just made. Now, depending on what you decided, here's what the empirical picture looks like for adult speakers of English and children speakers of English. So basically, all adult speakers of English think, yeah, this is a great way of describing this scenario. I think what Mary said is true. I would describe the scenario in this way. Whereas 5-year-old children are almost always rejecting this description of the scenario. So here is a salient difference between child and adult behavior. And we're trying to understand where that difference is coming from. Now, this sentence was chosen intentionally because it's an instance of what's known as scope ambiguity. So you have 2 logical operators here. You have the universal quantifier introduced by every, and you have negation. And depending on the relative scope of those 2 logical operators, you can get one of 2 interpretations. So if you interpret the logical operators in the order that they appear in the surface structure, with every taking scope over negation, you're saying for each horse, it's not the case that that horse jumped over the fence. A good paraphrase of that would be none of the horses jumped over the fence. But if you interpret the negation over the universal, you're saying it's not the case that for each horse, that horse jumped over the fence. There, the paraphrase could be not all of the horses jumped over the fence. Now, if we come back to that scenario, note that it's only the inverse interpretation that's true of this scenario. And so you might then conclude that the difference between adults and children is that adults have no problem accessing that inverse interpretation, and that's how they can say, sure, the sentence is true. Not all of the horses jumped. Whereas children are stuck with the surface interpretation, and it is not the case that none of the horses jumped. 2 out of 3 of them did. Now, if that were the end of the story, this would be a very short talk, but it gets more interesting because there are subtle changes that you could make to this task to make children more adult-like in their behavior. What that means is we can make them endorse that utterance more. So here's one change that people have tried. It's known as an explicit contrast manipulation. So before you get the critical every horse didn't jump over the fence, you hear something like every horse jumped over the log. So they're responding to every horse jumped over the log, but every horse didn't jump over the fence. And from 10 to 20% endorsement, now they're all the way up at 60% endorsement. And so the question is, what is that manipulation doing to push around children's behavior? And what does it tell us about the knowledge they have of this ambiguity? Now, there have been three types of manipulations in the literature to get kids to endorse the utterance more. There's explicit contrast, which I just showed you. There's something known as early success. There's also what's known as unambiguous priming. According to the authors who came up with these manipulations, here's what they think these manipulations are doing. First, we think that these manipulations are affecting the felicity conditions of negation. So sometimes it's weird to just utter negation out of the blue. You need the appropriate context so that you have something to negate. And so maybe what we're doing with these manipulations is creating that context that allows the negation to be more felicitous. We might also be priming some abstract level of representation in the logical form, right? So making it easier then to access an interpretation later if we've accessed it earlier. That's according to the authors of these manipulations. But I'd like to convince you that there's more than meets the eye with these manipulations. And to see that, let's actually walk through what's happening with them. So back to this explicit contrast manipulation. The way these truth value judgment tasks work with kids is you're acting out with puppets what's going on, right? We want to keep the kids engaged. Let's get them cute puppets. Fine. And so they see the scenario acted out. The horses are all jumping over the log, and then we see 2 out of 3 horses jumping over the fence. So by telling people that every horse is jumping over the log, you're potentially informing them about the horse's jumping ability, which might then affect their expectations about which states of the world are more or less likely. If I know they all jumped over the log, then maybe it's likely for them all to jump over the fence. Maybe I've created that expectation about specific states of the world. By telling them that every horse jumped over the log, I might also be biasing them toward a specific topic of conversation or question under discussion. So if I hear every horse jumped over the log, then maybe I expect to be told next whether every horse did something else. Is it the case that every horse jumped over the fence? So just with this explicit contrast manipulation, I'm plausibly affecting both expectations about states of the world and expectations about QUDs, or topics of conversation. Now, with the early success story, it's basically the same thing. I've just embedded that early success that you got in the explicit contrast in the story context. So people encounter a story like this, and again, it's all being acted out. So 3 horses decide to have some fun jumping over things. 1 horse jumps over a cow and then challenges the other 2 horses to do the same. The other horses jump over the cow, one after the other. Then the first horse jumps over the pig and challenges the other horses to do the same. The second horse jumps over the pig. The third horse considers jumping over the pig, but decides that the pig looks scared and approaches him. The pig is in fact scared, so the third horse just talks with him instead of jumping over him. And then the test sentence is, every horse didn't jump over the pig. And kids are endorsing this at like 80%. Okay? What's happening here? Well, I've told you about the horses jumping over the cow. They've succeeded in doing this. So as with the explicit contrast, I might be then biasing your expectations about states of the world that are more likely. Maybe I think I'm dealing with really jumpy horses, so I expect them to all jump over the pig as well. And also, by telling you that they've all jumped over the cow, I might then set up the expectation for a QUD that concerns whether or not they all jumped over the pig. So again, I could be affecting world expectations, QUD expectations, just with this one manipulation. Finally, you have the unambiguous priming, where early on you encounter the inverse interpretation unambiguously. So you see something like, not every horse jumped over the cow, where you have the configuration negation over every. And then later on, you encounter the ambiguous sentence, every horse didn't jump over the fence. And the idea is, by virtue of having created this structure with negation over every previously with this other sentence, it makes it easier for them to reuse that structure later on for the test sentence. So it's affecting the accessibility of the logical form corresponding to the inverse interpretation with negation over every. So that could very well be happening with this unambiguous priming, but I'm also telling you things about the horses and their jumping abilities, telling you that they didn't all jump over the cow. So as with these other manipulations, I could also be affecting people's world knowledge expectations about likely states of the world. I could also be affecting their QUD expectations. So we're left with a picture that looks something like this, where each of these 3 manipulations could be affecting expectations about the world, expectations about the QUD, accessibility of the logical form. Now, you can divide these factors according to whether or not they concern pragmatic reasoning, expectations about the world or the topic of conversation, versus grammatical knowledge, so the ability to access the logical form corresponding to the inverse scope. And what we'd like is a way of teasing apart these potentially independent contributions from world knowledge, QUD, logical form, in the behavior that we're measuring in these truth value judgment tasks, right? So how are we going to tease apart these potentially independent contributions? Well, we're going to use computers to code up computational cognitive models of the utterance disambiguation process as we envision it in these truth value judgment tasks. So the model that I'm going to present to you is formulated within the Bayesian Rational Speech Act modeling framework. And this RSA modeling framework views language understanding as recursive social reasoning between speakers and listeners. So speakers reason about listeners as they're selecting their utterances, and listeners reason about speakers as they're interpreting the utterances. So in a little bit more detail, the speaker and the listener are coordinating on the utterance and the interpretation that is most likely to correctly resolve whatever question happens to be under discussion, where the default question under discussion is, what is the state of the world that I'm trying to describe to you? So the speaker observes the state of the world and then chooses an utterance to communicate that state of the world to the listener. The listener hears the utterance and infers, what was the state of the world that led the speaker to select the utterance that I'm hearing now? Okay, so everybody's reasoning about each other in this recursive social reasoning. Now, to get you thinking along the lines of the intuitions that this model is trying to capture, I want to imagine that you're in one of these simple reference game scenarios where you're trying to communicate one of the objects, namely the one being pointed to by the arrow there. And you're a speaker, and I've tied your hands. You can only use these single word utterances. So you can say blue or you can say circle. So ask yourself, which of those utterances would you choose to communicate the object that's being pointed to by that arrow? Record that intuition very carefully in your mind so you can retrieve it later. And then let's flip around and imagine that you're a listener. Okay, so now you've heard a single word utterance, you've heard blue. Which of these objects do you think the speaker is trying to communicate to you? Let's assume that the speaker is speaking literally, so they don't mean the blue object. So your job is to figure out whether or not they're trying to communicate the blue square or the blue circle by saying blue. Okay, so interrogate your intuition, record your intuition, and then we'll come back to it. So the model is trying to model exactly the sort of reasoning that you just engaged in. And the way that it works is via these nested layers of inference. So the good news and also the bad news is it's all just a bunch of math. So the math grounds out in what's known as a naive hypothetical literal listener. So each of these reasoning agents can be characterized by a conditional probability statement. So the literal listener is performing this task here, right? I hear blue, and I'm going to return a probability distribution over states of the world that I think that utterance is meant to describe. The way that I do that is by reasoning about the literal semantics of the utterance. Okay? This is just a simple truth functional semantics. So if you're not familiar with truth functional semantics, here's what we're working with. So suppose that the utterance is blue and the state is blue square. That's going to map to true, or 1. Suppose the utterance is blue and the state is the blue circle. That will also map to true, or 1. Suppose that the utterance is blue and the state is the green square. That'll map to false, or 0. Okay, so now you know truth functional semantics. So this is how the literal listener is creating this probability distribution. I've heard an utterance and returning a probability distribution over states that I think that utterance is meant to describe. Now, in this example here, the literal listener is going to return a flat probability distribution over the 2 states of the world that are compatible with the literal semantics. So I'm just filtering out the states that are incompatible with the semantics of the utterance that I heard. So according to the literal listener, if I hear blue, there are 2 things that are blue, and I don't know which one among those 2 is more likely. Okay, so that's the literal listener. One layer up, you have a pragmatic speaker. So the pragmatic speaker is performing this task. They observe some state of the world S, and they return a probability distribution over utterances with which to communicate that state of the world to the literal listener. So there's a bunch of math going on here. There's two pieces that I want to draw your attention to. The pragmatic speaker is trying to maximize the probability that the literal listener arrives at the correct state given the utterance. So they want to make sure that they're communicating the right meaning. And they're trying to minimize this thing, which is the cost of the utterance, because we're lazy and we don't want to say costlier things than we need to get across whatever meaning it is that we're trying to communicate. So these two things are balancing. One is informativity. I want to get the literal listener to arrive at the correct state, but I want to be economical while I'm doing it. And so I'm trying to minimize cost. Okay, so in this example here, where we're trying to communicate the blue circle, this is what the speaker is going to return. So the speaker is going to be twice as likely to say circle than they are to say blue. This is the point where you recall your intuitions and ask yourself whether the model is matching your own intuitions. Now, why is the speaker twice as likely to say circle as blue? Well, because the literal listener is twice as likely to arrive at the correct state if they hear circle. So if they hear circle, there's a 100% chance that they get the right object. If they hear blue, there's a 50% chance. Right? So it's twice as likely that the literal listener arrives at the correct state if we hear circle. And so the speaker is twice as likely to choose to say circle to describe that state to the literal listener. Good. Okay, so that's the speaker. And at the top, you have what's known as the pragmatic listener. This is you or I as we're understanding language. We're very sophisticated. That's why we wear the hat. So the pragmatic listener is performing this task again. I hear an utterance, and I'm returning a probability distribution over states that I think that utterance is trying to describe. So probability of S given U. But rather than reasoning directly about the semantics, which is way down here in the literal listener, the pragmatic listener is reasoning about the process that generated the utterance that they heard. And the process that generated the utterance they heard is called the speaker. So the pragmatic listener starts with some prior beliefs about which states of the world they think are more or less likely before they hear anything at all. So let's start by assuming that those prior beliefs are flat. So I'm updating flat prior beliefs with the information that the speaker chose to say the thing that I heard, namely blue. So what the pragmatic listener does is they say, okay, which state is most likely to get the speaker to say blue? We saw with the blue circle that there's a 33% chance that they'll say blue. For the blue square, it's 50-50. There's a 50% chance they'll say blue. There's a 50% chance they'll say square because they're both equally good at communicating to the literal listener. And so what happens is the pragmatic listener says, well, then I think the blue square is more likely here because the blue square was more likely to get the speaker to say blue. And that's what I heard. Now, again, you can recall your own intuition and decide whether or not this model is matching the intuition that you had in this scenario. But this is a full version of an RSA model. This is the full vanilla RSA model, and I've shown you the predictions that come out of it. In order to get this model to handle ambiguity, we need to complicate it a little bit. So what we're going to do is we're going to parameterize this interpretation function by some interpretation resolving variable here, I. And so what happens is the literal listener hears the utterance and is told, oh, by the way, this is the interpretation that you should interpret it with. And then they infer what the state is for that utterance with that interpretation. The speaker observes the state of the world and knows the interpretation that they have in mind, and then chooses utterances to communicate that state of the world with that interpretation by reasoning about how the literal listener would interpret it. And now the pragmatic listener has to do two things at the same time. I hear the utterance, and I have to figure out what's the state of the world and which interpretation did the speaker intend. So I have prior beliefs about the interpretations that are more or less likely, and I have prior beliefs about the states that are more or less likely, and I'm updating both prior beliefs with the information the speaker chose to produce the utterance that I'm hearing. So for ambiguity, schematically, imagine we have some ambiguous utterance, and then we have this variable I. We'll say, if I is true, interpret it as U1, otherwise interpret it as U2. Now, coming back to these cases of scope ambiguity, we have sentences like, every horse didn't jump over the fence. We'll say, if I is inverse, then interpret it as inverse, not all. Otherwise, interpret it as surface, none. So what's the semantics for these things? So in a world where we have three horses, none is going to be true just in case the state is 0. So we're identifying states with the number of horses that succeeded in jumping. So none means none. And then not all is going to be true just in case the state isn't 3. Because we have 3 horses, so we're saying it's not the case that all 3 of them jumped over the fence. Okay, so that's the semantics that we're working with in this model. And then it feeds back into our vanilla RSA, now parameterized by interpretation. So now a pragmatic listener hears something like every horse didn't jump over the fence, and they have to figure out the number of horses that jumped over the fence and which interpretation, surface or inverse, the speaker was intending. Okay, so that's how we're going to handle ambiguity resolution, but we want to add in another piece of technology to this model. Right now, there already is a QUD implicit in this model. The literal listener is trying to infer S, given that they've heard some utterance. And remember, S corresponds to the number of horses that succeeded at jumping. So the QUD that's implicit in this model is how many horses succeeded in jumping over the fence? And that's the question that the speaker is trying to answer for the literal listener. What we'd like is some other QUDs that are possible as well. So for example, did all the horses succeed at jumping over the fence? Did none of the horses succeed at jumping over the fence? The way we're going to model these QUDs is as partitions on the state space. So the how many horses QUD is just going to partition that state space into 4 cells. And the speaker is trying to communicate to the literal listener whether we're in this cell, or this cell, or this cell, or this cell. Okay? For the all QUD, did all of the horses succeed at jumping over the fence? Now the speaker is just trying to communicate, are we over here? Yes, all of the horses succeeded. Or over here? No, it's not the case that all of the horses succeeded. Beyond that, it's up to you, the listener, to figure out exactly how many. All I'm trying to tell you is yes or no, whether all of the horses succeeded jumping over the fence. And then for the non-QUD, the partition will look like this. So is it the case that none of the horses succeeded? Yes, no. And the speaker is trying to communicate whether we're in this cell or this cell of the partition. So those are our QUDs. We're modeling them as partitions on the state space. And what the literal listener is going to do now is hear the utterance, be told the interpretation that's intended, be told the QUD that's trying to be addressed, and then infer the answer to the QUD. We'll call this X. This is where the math starts to get even more complicated. So I'm happy to go through this in more detail during the question period. For now, the thing to notice is that our literal listener is inferring the answer to the QUD, and the speaker is trying to communicate that answer to the QUD to the literal listener. So the speaker knows the QUD, they know the interpretation they intend, they know the state of the world they're trying to communicate, and they're choosing an utterance to communicate that answer to the literal listener. Now the pragmatic listener has even more that they need to do. They have prior beliefs about the states of the world, the interpretation, and the QUD now. And they have to jointly infer what the state is, what the interpretation is, and what the QUD is on the basis of just hearing the utterance. And I think this is rather plausible. You're in a conversation. The only information that I get from that utterance is every horse didn't jump over the fence. And I have to jointly infer all these other things while I'm trying to interpret this utterance. Now, with the model set up like this, these priors are like knobs that we can turn to explore the analytical behavior of these models. So for this prior on states of the world, we can turn that knob between an expectation for super jumpy horses versus an expectation for super lazy horses and see what effect that has on interpretations. This is a way of exploring how these things could be affecting the behavior in the truth value judgment task. For the prior on QUDs, we can turn that knob. We could favor, say, the how many QUD or the did all the horses succeed QUD. And for the scope prior, we can turn that knob and favor a surface interpretation or an inverse interpretation. So by turning these knobs of the prior, we're going to explore the downstream effect on interpretation that these factors might have. But I think we need to take a step back and ask ourselves, what is it that we're trying to model? What is the behavior that we're trying to model? We're trying to model truth value judgments. So in a truth value judgment, recall, you observe the state of the world, you're given an utterance, and you're trying to decide whether that utterance is a good description of that state of the world. We think this is better described as utterance endorsement. Would I choose to say this utterance as a description of this scenario. And when I phrase it like that, what I'm describing is speaker behavior. The speaker is observing the state of the world and choosing whether or not to say this thing. This is kind of counterintuitive if you think of truth-value judgments as telling you something about interpretations. But I think the behavior that goes into generating them is better modeled as speaker production behavior. Now, in our model, we have a speaker layer that we can generate predictions from, but unfortunately, the speaker won't do for us. In the truth-value judgment task, all you get is the state, and you're trying to decide whether or not you'd say the utterance. In order to get predictions out of this speaker, they need to be told the state and the interpretation and the QUD. We want a speaker who just needs the state and then returns a probability distribution over utterances. So we need a speaker who's going to reason about the pragmatic listener. So we have one additional layer in our model. So the S2 speaker observes the state of the world and chooses an utterance to describe that state of the world to the pragmatic listener. And they say, okay, pragmatic listener, I don't care what you infer about the interpretation or the QUD. We're going to marginalize over those things. I just want to make sure you get the right state. So whatever you do for the interpretation and the QUD, I'm just trying to choose utterances that are best equipped to communicate the state to you. Now, in this model, we're making an interesting choice here about what are the possible utterances that the speaker could say. So we're saying that they could either say the ambiguous every not utterance, or they could say nothing at all. So in the truth-value judgment task, you have two choices. You can say, yes, I would endorse this utterance as a description of the scenario, or no, I would not endorse the utterance as a description of the scenario. That's what these choices are meant to model. So yes, I would choose every not to describe it, or no, I'd rather not say anything at all and let you rely on the information you already have in the form of your priors, than potentially do harm by introducing bad information with every not. Okay? So this is the model as presented in this 2021 paper with my colleague, Lisa Pearl. If you're curious, the details are available there. The model is also available online in a browser-based implementation where you can play around with the code in your web browser, if that's something that's interesting to you. Okay, so this is the full model that we're generating predictions from. The prediction that we're going to generate is the probability that this S2 speaker would choose to say every horse didn't jump over the fence to communicate about one of these not all scenarios where 2 out of 3 horses jump over the fence. So what is the probability of saying, yes, that's a good description of that scenario, or providing a yes answer on a truth-value judgment task? So I'll plot the results by manipulating, turning these knobs of these priors. The y-axis here is the probability of endorsing that ambiguous utterance as a description of the not all state. Higher values mean you're more adult-like. Lower values mean you're more kid-like. The first thing that we'll look at is the scope prior manipulation. So on the x-axis, I'm modeling the prior probability of the inverse not all interpretation. So as we go from left to right across this axis, I have a stronger prior expectation for the inverse interpretation. And as that expectation for inverse increases, I'm getting more endorsement. And that makes sense because only the inverse interpretation is true of this scenario. So if I'm more likely to interpret it as inverse, I should be more likely to endorse that as a true description of the scenario. Okay, so that's kind of like a sanity check. This is what we would expect. Now let's look at these pragmatic factors. So for the world prior manipulation, what I'm modeling is expectations for whether 0 horses, 1 horse, 2 horse, or 3 horses succeed at jumping. So it's like going from lazy horses up to jumpy horses. And you'll notice there's a huge increase in predicted endorsement probability as I go from lazy horses to jumpy horses. We'll come back to why that's the case. Finally, here's what happens with the QUD manipulation. So as I go from an expectation of a QUD, which is did none of the horses succeed, to how many horses succeeded, to did all of the horses succeed, I'm getting a marked increase in predicted endorsement probability from the model. The thing to notice, and that really jumped out at us, is that the pragmatic factors here seem to be having a much bigger effect on the predicted endorsement than the scope prior manipulation, the access to the inverse scope interpretation. And we can see the outsized effect of the pragmatic factors relative to the grammatical factor if we allow these things to interact. So this is what I'm showing you here. So here I'm generating predictions from a model where I have expectation for really jumpy horses. I have an expectation for did all the horses succeed at jumping QUD. And on the x-axis, I'm manipulating the scope prior from a really low prior probability of inverse to a really high prior probability of inverse. And it has next to no effect on the predicted endorsement. These pragmatic factors are totally overwhelming this grammatical processing factor. And the reason why they're overwhelming it is because endorsing the utterance, every horse didn't jump over the fence, with these pragmatic conditions, doesn't require any disambiguation at all. And this is potentially surprising. So if I'm trying to tell you, no, it's not the case that every horse jumped over the fence, and your expectation that all of those horses would jump doesn't hold, this is a super informative way of doing that. Under either scope interpretation, none or not all, I'm telling you that the answer is no, and it's not the case that all of the horses jumped over the fence. You don't have to disambiguate to get that information from this utterance. And because of that, it's super useful to the speaker, and the speaker is going to be more likely to endorse it. Okay, so informativity appears to be ruling the day for these truth value judgments. And that's the worry for the truth value judgments. If we come back to this empirical picture, where adults are always endorsing it and kids almost never are, if we think this truth value judgment task was telling us something about the kid's ability to grammatically access inverse scope, now we have a problem, because I've shown you that endorsing the utterance requires no disambiguation at all, which means that these data tell us very little about kids' ability to grammatically access inverse scope. Instead, endorsing the utterance requires you to manage the pragmatic context in a way that allows you to figure out how that utterance could be informative. And adults seem to be able to do that automatically. They say, oh yeah, this would be an informative way of telling me about this sort of QUD or this sort of expectation. So I'm going to endorse this utterance. And it seems like kids struggle to charitably interpret these utterances and find ways to make them more informative. And that's where they need support from these experimental manipulations. And so unsurprisingly, the difference between kids and adults here appears to have to do with their pragmatic reasoning abilities, which is one of the last things to develop in language development. Okay, so that's the story from the model. Now I'd like to close with a little bit more empirical support for the predictions of this model. What leads us to suspect that this is a reasonable model of what's going on in this task? So in separate work with my students Youngja and Abimel, we experimentally manipulated the QUD with adult speakers of English. So the right side here, this is empirical. So if we have a condition where people expect the none QUD versus the how many QUD versus the all QUD, this is the rates of endorsing those every not utterances with those QUDs. And you'll see that it matches very well the predictions of the model. So we're getting good qualitative predictions out of the model and also decent quantitative predictions as well. So that seems to be support for the model. In a separate project with my student Noah Atali, we went into the corpus of contemporary American English, which contains radio and TV transcripts from about 20 years. So there's about 9 million clauses there, and Noah went and she found every single every negation sentence that she could in that corpus. So there's 390 of them. They're not super common, but they are attested. And what she did with those 390 every negation sentences is she put them into a paraphrase endorsement task, where people read the context in which these things were uttered, and then they adjust a slider between the inverse versus surface interpretation to indicate the interpretation that they're getting. So for something like everything is still not perfect, they tell you whether they think that means not all things are perfect or nothing is perfect. So we got ratings from 208 participants. We got about 15 ratings per item, and the average rating by item is plotted here. What you'll notice is there's a ton of variability, but there appears to be a bias toward inverse interpretations, the not all interpretation, in these naturalistic data. I think it's interesting to diagnose the variability on its own, but we wanted to use our model to see if we can explain some of that variability and see if we can find further support for the predictions of this model. So what Noah did is she came up with an automatic way of looking at the text of the context and inferring the state prior. Am I expecting lots of success? Do I have an expectation for super jumpy horses? Do I have an expectation for super lazy horses? And recall that the model predictions say, as I have a greater prior expectation for success, I should get more inverse interpretations. And that's what we're seeing in these data. So the y-axis is the average inverse, not all interpretation preference. And we've got this reliable positive correlation. Now, the other thing that you'll notice is there's a ton of noise here. So there's more going on than just the state prior in pushing around these interpretations. But this is encouraging for the prediction that we're getting out of this model with respect to that specific pragmatic factor. In a separate project, Noah looked at other quantifiers. So this ambiguity doesn't just arise with every. Whenever you have that logical configuration of quantifier and negation, in principle, you might be able to get this kind of scope ambiguity. So what she did is she looked at every negation, every horse didn't jump over the fence, no negation, no horse didn't jump over the fence, and some negation, some horse didn't jump over the fence. And she measured interpretation preferences, this is in yellow, and compared it to the model predictions in gray. So it's the exact same model that I presented to you, just adding in these other utterances and the appropriate semantics for those interpretations. And what we see is that we're getting good qualitative predictions out of the model, and again, good quantitative predictions as well. So it's not just a model of every negation, it seems like it's more general to this type of scope ambiguity more broadly. Okay, so coming back to this question that we started from, why is it that children are differing from adults? Is it their grammatical knowledge that's different or the way that they're using it in context? It seems like the clear answer from this exploration is it's pragmatics. It's the way that they're using that knowledge in context that's different. And that is unsurprising given what we know about language development. But you might be wondering, okay, so if the story is that adults are better able to charitably interpret these utterances to figure out ways to make them informative, kids have a harder time at that, and so they need some help from context to show them how it could be informative. There should be situations where adults struggle to make things informative too. There should be situations where adults start to look like kids. Right? And in fact, we find that. We find that with a different type of ambiguity with numerals and negation. So 2 horses didn't jump over the fence. This sentence is ambiguous. It could mean there are 2 horses that didn't jump. That's false here. Or it could mean it's not the case that 2 horses jumped over the fence. That's true here. Only 1 did. In this sort of scenario, adults really don't like to endorse this. They're only endorsing it about 20 to 30% of the time. Right? So it seems like they're having trouble with this sort of pragmatic context, just like kids were having trouble with the pragmatic context around every negation. But then, if children can be helped by a supportive pragmatic context, adults should be able to be helped by a supportive pragmatic context as well. And in fact, that's what we find. So if you add in this explicit contrast manipulation, where adults see 2 horses jump over the cow, and then 2 horses didn't jump over the fence, now they're endorsing it at ceiling. So adults are benefiting from supportive pragmatic context, just like kids do, which suggests that this model is general and applies both to the adult reasoning and the child reasoning. Okay, so that's my cautionary tale for the truth value judgment methodology. If we want to use truth value judgments to tell us something about the semantics, we've got to understand the pragmatics that goes into generating these truth value judgments. And I hope to have convinced you that we can make some progress understanding the pragmatics underlying these truth value judgments with just a little bit of math. Okay, thank you very much for your attention, and I look forward to hearing what you guys think.
Okay, thank you, Greg. So now QA section, okay? So any questions? Oh, I just have one clarification question. So you talk about QUD a lot, right? But I think that a lot of master program students do not know about QUD. Can you say more about QUD?
Yeah, so the best way to conceive of QUD is the topic of conversation. What's the thing that we're talking about? It stands for question under discussion, but it's really, what is it that we're talking about? So are we talking about the number of horses that jumped in the case of this example that I gave you? Are we talking about whether or not all the horses jumped? Are we talking about whether none of the horses jumped? These are different potential topics of conversation. And what I'm trying to show you with this model is that depending on which QUD you think you're dealing with, you get very different predicted endorsement behavior in this task, right? And so I think that feeds back into these empirical observations about manipulations to the truth value judgment task. What could plausibly be happening with these manipulations? Well, it could be that you're affecting people's expectations about the state of the world and about the QUD, and that's what's pushing around the behavior.
Okay, thank you. Vanessa.
Hi.
Yeah, please identify you first. Yeah.
Excuse me, what? Sorry. Okay,
yeah, please,
so can I?
Please identify yourself first. Thank you.
Oh, hi. My name is Vanessa. I'm a master's degree second-year student from Yangming Chiaotong University. And this is a really interesting topic. Thank you for bringing this to us. I have a question considering about probably methodology concerning the model. So when you're asking them to make a decision, do they know what they are trying to focus based on the story you just told them? Like, is there determination acts after the whole story being told or before, so that they can know what they should be focusing on? So if they know before knowing the whole story, like, oh, you are gonna be asked how many horses to see jumping off the fence, then I think the order might matter for the later decision or determination.
Yeah, so in the model, when we're generating predictions from the speaker, I just observe the state of the world, and I return a probability distribution over whether or not I'm going to endorse the every not utterance. In the task itself, the tasks that I've been presenting to you, you see the whole state acted out, so you know what the state of the world is, and then you get the utterance as a description from it. Some of them have tried to manipulate QUD, and what you find is if you try and bias them toward the all QUD, you get higher endorsement, which is exactly what this model is predicting. But what the story that I'm trying to tell with the model is what's happening with these experimental manipulations is you're shifting around these priors. You're shifting around expectations about which QUDs you think are more likely, which scope interpretation is more easily accessed, which states we think are more likely. And then by changing these things, I'm going to change the predicted endorsement behavior. So there's the order that we're imagining for what we're modeling here is you have an experimental manipulation, which is in place before you get the utterance or before you observe the state. That's changing these priors. Then you get the state together with the utterance, and you have to reason with these updated priors.
Okay. And may I have a follow-up question? So in terms of the three probability you just raised, is there any interaction or hierarchy existed in between, or they treat the three probability equally? Like,
yeah, so in our model, we're treating them as separate. We're treating these things as independent. Now, my reasoning, because these things are being jointly inferred, whatever I infer about this thing is going to affect what I infer about this thing, which will affect what I infer about this thing. Everything is interacting with everything. That's where these models become useful. Because the reasoning, as I've described it, I mean, this is something that you can think through. You don't need a computer to tell you. But when you're trying to generate these quantitative predictions, because these things are all highly interactive, that's where the model is useful at being able to isolate the contribution of single factors. So I can change one of these things at a time, whereas in these experimental manipulations, you're trying to approach something with a scalpel, but you're really using a hammer. And so you're probably affecting everything all at once.
And my last question, if nobody's gonna raise, I have a last question. So now you're looking in English, right? And I'm wondering if you have any consideration about maybe cross the board, looking at probably, for example, Japanese, because they use this confusing phrase, maybe their cultural roots, that derives from their expression. Like they use a lot of negation within one utterance. So is it possible for kids in Japanese, speaking Japanese as their native language, they might be more adult-like earlier comparing to the English counterparts?
Sure. I mean, it's certainly possible. I think with a lot of this, it's really an open empirical question. It's complicated by the fact that not all languages are as permissive as English when it comes to these types of ambiguity. So, for example, Mandarin is a language that we've spent a lot of time thinking about, where it seems really difficult to get these inverse interpretations. And part of the motivation for this study with Youngja and Abimel was to explore, is it the case that the reason you're not getting the inverse interpretations in Mandarin is because the context isn't sufficiently supportive? And so if we could make the context more supportive, for example, with biasing you toward an all QD, our Mandarin speaker is going to be more likely to endorse these things as descriptions of the not all state. So we ran this experiment also in Mandarin, and it's basically flat. The QUD has no effect here, no measurable difference across them, suggesting that it's not, there's something grammatical going on in Mandarin that's making it very difficult for you to access these interpretations. So I think we have to approach it language by language. What's going on with the grammar? Which interpretations can it generate? We also looked at Spanish in this project, and Spanish looks more like English in the sense that the QUDs are pushing things around.
That's fascinating. Thank you very much.
Yeah, you're welcome.
Yeah, definitely.
Yeah, thank you, Greg, for the interesting talk. I was thinking about the Mandarin case for this kind of model. And you said that there was no such funding, similar funding for Mandarin. So would you doing the experiment for adults or kids for the Mandarin experiment?
So the empirical work that we've done was with adult speakers of Mandarin.
Adult? Then how about kids, children? Because you were saying that for kids, if you provide more pragmatic information, computational information, then they have higher, better way to get the inverse scope, right? More probable.
In English.
Yeah.
In English. But yeah, English-speaking children are, and again, these are 5-year-olds, right? So they're sort of like ancient when it comes to language development. It's just that their pragmatics are still developing. But we think most of their syntactic knowledge is pretty fixed by then.
Okay. So what was the model overall? I mean, for the structural thing for children. So, I mean, what was your expectation for Mandarin children if you do this empirical test to them? What's the role of structural properties in this kind of model? I'm wondering.
Yeah, so I think of the model that I presented to you as a model of a language that allows inverse scope. And so if Mandarin is not a language that allows inverse scope for these sentences, then we need a different architecture there. And it's actually an interesting puzzle for this model, because the model is like a heat-seeking missile for finding ways of making things informative. But if you have a grammatical prohibition on top of that that says, but you can't do it with this sort of structure, then that's something that you would need to add on top of the model. So right now, the model is for English-speaking adults, kids, it doesn't matter. It's just people with a mature grammar. And then for Mandarin-speaking kids, if by 5, we think they've internalized whatever structural facts are relevant, then I think the expectation would be that they'd be behaving similar to adults. Maybe they'd be a little noisier, but they should be resistant to these things. The reason I'm hesitant to fully endorse that prediction is because I have a vague recollection of some empirical work that people have done. And I think it was on Mandarin-speaking children, but I can't for the life of me remember the reference. And I think what you find is that they're a little bit more permissive than the adults. They certainly don't like English-speaking adults, but it looks like they're a little more permissive. I need to figure out where that memory is coming from. But it's a great question. Do you have intuitions, Daphne, about what Mandarin-speaking children are doing?
I don't know. I think if you give me because we know, I mean, some people here, some children here learn English at an early age. So if you give them like a lot of contextual clues, maybe they were able to like get some kind of Mandarin English behavior. I think it's possible, right? Because they are influenced by.
Yeah. So
I don't know.
I share this hunch in a separate project. We were looking at a different type of ambiguity. So ambiguity that you get with existentials and universals, like a child read every book. And in English, that could mean there's a single child that read all the different books, or it could mean for each book, there's a different child that read it. And in Mandarin, as far as I can tell, that is not possible. You can't get the inverse interpretation for those sorts of sentences. And so what we did was we looked at English dominant heritage speakers of Mandarin. And so this is a case where you have a bilingual. They've got both of those systems inside of their head. And we were thinking, okay, will the English system bleed over into the Mandarin system such that you can get inverse interpretations for the Mandarin sentences? No, the simple answer is no. In Mandarin of these bilinguals, they don't like the inverse interpretation. And the real surprise came when we looked at their English, because in English, they didn't like the inverse interpretations either. So if anything, it appeared like the influence was coming in the other direction. The Mandarin grammar, which is more restrictive, less permissive in terms of the scope options, is bleeding over into English. So yeah, I think looking at bilingual children is a great next step for all of these cases of ambiguity.
Okay, Professor Liu.
Yeah, can you hear me?
I can.
Yeah, thank you for Greg's talk. Yeah, first of all, I have to say I'm an UCI alumni.
Oh, wonderful.
Yeah, I got my PhD in linguistics from 1999, chaired by Professor Jun Huang. Okay. I really enjoy your talk. Okay. If I understand correctly, it seems you want to argue that kids need more pragmatic context than adults to interpret sentences involving quantifiers and negational markers, right? Okay, so my question is this, okay? For a syntactician or semanticist, we always use quantifier raising. It's a kind of syntactic operation to deal with the ambiguities raised by sentences like what you are talking about in today's talk. And following Chomsky's reasoning, he wants to say syntactic operation is morphological driven, right? Okay, and based on my understanding of your talk, it seems kids need more pragmatic context, okay, to decide whether we need some kind of syntactic operation like QR, okay, for kids to interpret sentences. So can we say for children, the syntactic operation is pragmatically driven, and for adults, the syntactic operation, in some sense, is morphologically driven. This is one of my questions. And another question is this. Suppose we have some kind of language which has rich morphology related to QR, I mean quantifier raising. So if we have this kind of sentence, since children do not well capture the morphology. So they need more syntactic, not more pragmatic context, okay, to endorse, I mean to help them to interpret such kind of sentence. For adults, since they will capture or comment the morphology, okay, so they might not need pragmatic context, or they only need a little bit of pragmatic context, and then they can interpret such a kind of sentences well. Okay, this is my question. Okay, thanks.
Yeah. Okay, good. So these are great questions, and I think I need to take a couple steps back, because the real takeaway from this investigation, I think, comes here, where a lot of the behavior that you could be measuring this task can be explained without attributing any sort of disambiguation, QR or otherwise, to the children, to the adults. Part of the lesson is it doesn't matter what scope interpretation you assign, as long as that utterance is informative for whatever conversational goal I have, then that's a good utterance, right? Regardless of how it gets disambiguated. And in fact, I'm most likely to use these things when, regardless of how it gets disambiguated, it's informative. So that's what we're finding. And so if I go from a really unlikely inverse interpretation to a really likely inverse interpretation, it's having no effect on the predicted endorsement if I have the appropriate supportive pragmatic context. And so I don't think that we can use these truth value judgment data to tell us whether or not anybody is performing QR. I think that's part of the problem. This is the more pessimistic viewing of these results. I don't think that it's hopeless. In fact, I think that when you do the work to really understand the pragmatics that go into these truth value judgments, it's a useful tool. And in fact, the people in the language development literature have known that pragmatics plays a huge role, and that's a big consideration when they're designing these truth value judgment tasks. But for the working semanticist who says, I want to take a methodology off the shelf and figure out which scope interpretation someone's getting, I view this as a sort of a caution call, right? Maybe slow down a little bit and make sure you understand what's going on with the pragmatics here. So I think it's a compelling idea that things that adults can do morphologically requires pragmatic support for children. But I don't think that these truth value judgment data are going to help us make that argument.
Yeah, okay. Thank you for your answering. Okay. Further question is this. Okay. Since as far as we know, Mandarin Chinese is a language. Okay. We have to say almost without any grammatical morphology. So that means pragmatic context plays a real crucial role to help us to interpret sentences like involving quantifiers or even involve structure elements. Okay, so is it possible for us to say for Mandarin speakers, okay, either adults or kids, they need more pragmatic context than speakers of languages with more morphology than Chinese? Okay, that's my second question.
Yeah, I mean, I think this is an argument that can be made. So if the linguistic form doesn't do the job of fully specifying the intended interpretation, then you're going to have to rely on whatever knowledge you already had to figure out what the intended interpretation is. So in this sort of modeling framework, I think of that knowledge that you already have as priors, but I'm going to need something else to help me figure it out. And so if you can convincingly argue that, for example, with Chinese and less inflectional morphology, there's more, let's say, information gaps or interpretive options, then yeah, you're going to have to figure it out one way or the other, and pragmatic reasoning is going to be what you use. At least I think that's going to be the most natural go-to to fill in those information gaps. Curiously, so in a separate line of research, I've been thinking a lot about why we have ambiguity in the first place. Like why do we have these information gaps? It seems like it should get in the way. And this is like the reason you get out of Chomsky. Language isn't for communication because we have ambiguity, and ambiguity gets in the way of successfully communicating. But it turns out that watching people resolve the ambiguity, so if I produce an ambiguity and then I watch you interpret it, I watch you disambiguate, I'm learning something about that prior knowledge that you have. It's kind of an indirect sneaky way of doing it, but it seems like there is this potential benefit to having ambiguity in language because it's a way of indirectly inferring things that would otherwise be private. And so this is an argument that I'm trying to make, I think, about ambiguity more broadly, but it feeds back into what you're describing. If the form doesn't fully resolve what interpretation it is, you're going to have to rely on something else. By watching you resolve it, I've learned about these other things that you were relying on to do it.
Okay, thank you very much. I really enjoy your talk. Thanks.
Yeah, thank you. Thank you.
Anyone? Matt.
Hello, can you hear me?
Yes.
Yep.
Okay, my name is Meg, and I'm also a master's student from NYCU. And I just found a really interesting point in your presentation that when you ask participants to describe blue among blue square, blue circle, and green square, and when you say blue, the result shows that people who answer square is almost the same as the number of people who answer circle, right? It's kind of half-half.
So are you talking about this result here?
I think not this one. I think it's former. Yeah, this one. It's,
okay.
So when someone say blue, then those who answer circle is the number is the same as those who answer square, right? And actually, it's kind of different from my intuition because I thought the number of who answer square is going to be a little bit higher than the circle one. Because when we are communicating, I thought that, especially in one word, we tend to use the most distinct feature that distinguishes it from the other. So like, if we want to say blue circle, then circle should be the most distinct feature. Mm-hmm. So we will say circle to imply the blue circle. Then if we say blue, it might be like representing a blue square. That's my intuition. And the result shows that it doesn't seem that it's the common case. So then my question is...
Hold on, Meg. So I think you've beautifully described the reasoning that the model is actually performing. So the predictions that I'm showing for you here, these are not these are model predictions. This is not results of human experiments. This is model predictions.
Oh,
and they're coming
okay,
from the layer of the literal listener who isn't doing any pragmatic reasoning. The literal listener is just updating prior beliefs according to the literal semantics. So they're returning a flat probability distribution over states that are compatible with the semantics of the utterance that they heard. So they have no way of choosing among the blue things if they hear blue. But this is not a model of us.
Okay.
So this is a model of the listener inside of the head of a speaker who's trying to choose utterances. The model of us comes from the pragmatic listener. And the pragmatic listener predictions from the model actually break the symmetry and the semantics in the direction that you intuited. So we're expecting that the pragmatic listener thinks it's more likely to be talking about the blue square than the blue circle. And when I, have people raise hands or whatever, that's the intuition that they report to me as well. So the pragmatics is able to break the symmetry and the semantics as you were hoping, as you described.
Oh, okay. I got it. Thank you.
Okay. Thanks.
Anyone? Well, I have one probably pretty naive question about your presentation. So given your talk, Greg, do you mean that Adele's judgment is not very reliable? Since it's changeable, and the syntheticians usually work on a lot of sentences, they try to ask for a lot of people's judgments. And since their judgments are manipulable, do you mean that we should not rely on Adele's judgments for certain types of sentences?
This is a great question, Louis. And no, it's not naive. It sort of gets at the heart of what the takeaway is supposed to be from this talk. And honestly, depending on the side of the bed that I wake up on, I have totally different perspectives on this. Mm-hmm. So I think the optimistic perspective is, no, we can still use this task and gather judgments as empirical data for theory development and proving. But the note of caution is, we need to understand what's going into generating these judgments. Specifically, we need to understand the pragmatics. And I think we can understand the pragmatics. It just takes a little bit more work. The pessimistic view of this is, no, stop running truth value judgment tasks. Maybe just deal with linguists' intuitions who can clear away the pragmatics junk anyway, and have a clearer view onto whatever we think is relevant. So yeah, depending on which day of the week you catch me on, I have each of these opinions.
Okay.
But I think I lean more toward the former. I think I lean more toward, go ahead and use these truth value judgment tasks if you want, but understand what goes into them. Honestly, I think the truth value judgment methodology is just really strange. It's not something that we do as speakers of a language usually.
Okay. Then the next question would be, what's the alternative that we can use to replace the truth value judgment?
Yeah, so what we did in one of the sets of results, and I just went right past it, but we use a paraphrase endorsement methodology. So like with these corpus annotations, you give people the interpretations that you're trying to disambiguate, and you ask them, which thing are you interpreting this as? So you come up with unambiguous paraphrases of the relevant interpretations, and then you say, well, which one do you think is more or less likely? That, I would argue, really is an interpretation task. All you've gotten is the utterance, and you're trying to figure out the state that utterance is meant to describe. And this, I think, is something that we do as we use language in day-to-day life. Okay. So yeah, I like the paraphrase endorsement task. I think with kids, it's harder. And that's why we've wound up with the truth value judgment task, because you can say, you know, does the puppet get a cookie? Did they say something correct? It might be a little bit more difficult to get them to really reason about paraphrases.
But what do their paraphrases look like?
So can you see this? So
Yeah.
I know it's really small here. I'm sorry. So everything is still not, this is a naturally occurring example from the corpus. And someone said everything is still not perfect. And so we paraphrase it as not all things are perfect still. So that's inverse. Nothing is perfect still. That's surface. We've validated these paraphrases in a separate task where we ask people to like click on the image that you thought you were describing, and they're doing what we want them to do. So if they hear not all, then they're imagining a some but not all scenario. And if they hear nothing, they're imagining a nothing scenario.
Okay, thank you.
Yeah, you're welcome.
Definitely.
Hi, Greg. I'm honestly, I don't like fully understand the models, but I'm really interested. So I want to know a little bit more about, I don't know whether you call it pragmatic speakers, speakers who think about the possible, like how he or she could provide QUD, different kind of QUDs to the listeners, some sort of thing like that.
Okay, so let's see, what level to, so.
Maybe I can make it more specific. I don't understand, when I'm trying to think about the whole model, there at least one point which I don't understand very clearly, that so if speakers have different options, why don't a speaker has different options, why doesn't that speaker choose the clearest way, a sentence which is not ambiguous at all? I still didn't.
Sure.
Yeah.
Yeah, so in this model, the only things that they can say are nothing, I don't endorse the utterance, or the ambiguous utterance. And the reason that we made that modeling choice is because in the truth value judgment task, those are your only options. You can either say, yes, this is a good description, or no, it's not a good description. So this is a side effect of the weird logic of these tasks. It's not the case that you can say, well, actually, I would have preferred to say it this other way. You have to give a truth value judgment. Then you can follow up with some reasoning that went into it, but you're making this binary forced choice. And so the reason why we don't include other utterances in the model that I showed you predictions from is because it's modeling these strange truth value judgments. But you can include other alternative utterances if you want, right? There's nothing that's stopping us. I think for the truth value judgments, it doesn't make as much sense. But for example, if I'm modeling listener behavior, so the results that I showed you here, these are actually generated from a listener layer in the model where I just hear the utterance and I'm returning the marginal posterior probability on the interpretations, inverse versus surface. And that corresponds to these slider ratings that we're measuring empirically. And in this model, you can add in, well, the speaker could have said several other things. Maybe they have the unambiguous paraphrase as an alternative utterance. And maybe that unambiguous paraphrase, because it's longer or even less frequent, is even costlier. Maybe that enters into the reasoning as well. And I think this is a promising direction to pursue. This was actually something that we looked into a little bit with the Mandarin data, because it seemed like in Mandarin, the way of expressing the unambiguous inverse interpretation, it's not like you have to add a whole bunch of stuff. You can just change around the order of things. And maybe that's not as costly as, for example, a passive structure in English or moving things around more severely. And so it seems like that can help explain a little bit what's going on in Mandarin. I don't like using the every horse didn't jump over the fence to describe inverse, because I have a very cheap salient alternative to describe just that. In English, maybe that alternative is less cheap, less salient. And so I'm more likely to use this other thing to express that meaning. But yeah, adding in other possible alternative utterances is definitely something that you can do, and it'll push around the behavior in these models.
Okay, thank you. Yeah, I'll think about that.
Okay, thanks.
Hi.
Hello.
Yeah. Craig,
Yes.
you might not know, okay? Your department, I mean, Department of Language Science, now is doing some kind of cooperation with our department. Because this year you have a new PhD student, okay? And he graduated from our department. Do you know who he is?
Is it Yiming or Chichao?
Zhichao.
Good.
Yeah. So now we are working together. Yeah, I really enjoy your talk. Okay.
I'm glad that we have these connections. That's great.
Yeah. So please say hello to him for me.
I certainly will.
Okay. Thank you very much.
Yeah.
So any other questions? Other students or Professor Chen? No? So is this your new project, Greg?
This is a project that I've been working on for basically since I first got to Irvine in 2016. So yeah, this has been something that we've been working on for a while. Okay. We're finally at the point now where I think we're doing more interesting stuff, checking the empirical predictions of these models. So that was the stuff that I was presenting at the end of the talk.
I see.
The other thing that we're excited to do is the corpus of these things that Noah put together. Recall that these are from radio and TV transcripts. So a lot of these have audio files that you can track down, and you can find the actual audio corresponding to these things. Mm-hmm. And so the next thing that we're working on is what kind of disambiguating information are you getting from prosody? And using these natural examples of the ambiguity in wild to try and figure out what cues and how it's working with prosody. So that's the next step.
I see. Vanessa.
I have a clarification kind of question. So when you were introducing about this QUD, right?
Yes.
You explained that maybe you can first, how would you call it? Maybe you can first put the ability of jumping into the kids' mind. So they would know that the horse is capable of jumping. And then you follow up by the discussion later. So they will know, like, maybe they cannot jump over the log, but they can jump over the fence or like whatever. But what is the chance that they might not be affected by this jumping ability, but the word but? Because like but is a strong word. At least that was my first intuition when you shows like every horse jump over the log, but every horse didn't jump over the fence.
Yeah.
I stress on the but more than, oh, actually horse can jump. So is there any, like, I don't know, it's kind of like external explanations about what is the,
I think it's great. I mean, we should be looking at absolutely everything. And so again, this is something that's specific to this manipulation, and it seems to increase endorsement. So what is the but doing? And I think the way that you're thinking about it is kind of along the lines of how the authors are thinking about it. There's something about felicity conditions with negation where I need something positive in the preceding context to negate. The reason why I don't think this is going to provide a fully general explanation for what we're observing is if you then jump to the early success story, there are no buts, at least not in the test sentence, right? So you get exactly the same information that you got in the explicit contrast, where all the horses succeed at one thing, and then 2 out of 3 succeed at something else. But you don't have that explicit but in the test sentence, and you have at least as high endorsement there. So maybe the but is doing the work in the explicit contrast, but it's not doing the work in the early success. So there's something else, maybe even more general going on. And so that's where these expectations about the pragmatic context, I think, come in.
I see. Another kind of like an embarrassing question. When you're telling this exact early success story, were they being told by auditory kind of signal, or they were shown in text and the kids read over the whole fucking the whole story and then make their decision? Because it was kind of hard to me. I don't know. I lost in the middle.
The way that it typically works is you have an experimenter with puppets, like little like horse, whatever, and a little doll pig or whatever, and they're actually acting it out for the kids. So they're saying it out loud and they're acting it out. So no, they're definitely not reading it.
Oh, what if 4 is a number you can still keep track on? What if today it's 100 horses and you tell the exact story about these early successes? What is the chance they are able to follow up to the very end of the story? Or maybe the probability might matter when there is a threshold, like after some certain amount of success, you will lose them.
Yeah, I mean,
I'm brainstorming, yes.
So it's an empirical question. We should see. I kind of share the intuition, which is as these stories get more and more complicated, the amount of information that children will be able to hold on to is going to be less and less. It could be interesting to think about what things they're more or less likely to hold on to. What that's doing to the prior. But in general, so the model that I presented to you is meant to be fully general. So if I'm giving you information that's able to update those priors, then we predict the effects that I showed you. What's happening with kids and their ability to retain information in the task, I don't know. Right? As this thing gets more complicated, I guess the question to ask yourself is, do you have specific hypotheses? Is that a hypothesis regarding memory in general, or something specific to the grammatical phenomenon that we're investigating? Because if it's about memory in general, maybe we don't need as complicated a test sentence to go after memory.
Okay. Thank you very much.
Yeah, thanks.
Any other questions? Okay, then if there's no more question, let's thank Professor Scontras for giving us this talk. Thank you, Greg.
Thank you very much. Yeah, and thanks for the questions.
All right. So let me stop video recording, okay?